it's Miss Kim. How are you today? I am so happy to see you because I am so excited. Would you like to know why? It is snowing outside and I love that. I am a Missouri girl and it snows quite a bit up there. So when I moved to Oklahoma 6 years ago, I've kind of missed that. So seeing it snow outside right now is exciting to me. And we're going to go out and play in it in just a few minutes. But I have a couple of questions for you before we even get started. Because you know Miss Kim, she always has questions for you. My first question is, how is snow made? I'm liking your ideas. Let's check it out. So I have my wonderful chart and I have some clouds up here. Now think of this, think of the water cycle, and when we have our rivers and our lakes down here and they start evaporating, when the sun comes out, warms things up and the water starts evaporating with that vapor and they come up into the sky, that's what forms the clouds. It's cold up here. So they freeze, the water molecules, the little water droplets freeze, and they start sticking together. And then once they stick together enough that they get heavy, they start falling out of the clouds. Now, when we get rain, that is when the ice particles fall out of the clouds and hit the warm air that's between the clouds and the ground. When it hits the warm air, those ice particles melt, and when it hits the ground in liquid form as rain. Snow, on the other hand, as you can already guess because you guys are so smart, is when the ice particles up here fall out of the clouds, and as they head towards the ground, they hit cold air, like what's going on outside right now. And that cold air and those ice particles hit each other, and what happens? They're both cold, so nothing happens right there. So when they hit the ground, that hits the ground as snow, and it's in a solid form, and that's what we got going on out there. It is awesome. I absolutely love snow. It's a natural phenomenon that I love to get out and play in. Now, natural phenomena, if you might not know, is things that happen outside in nature naturally, such as snow, rain, rainbows, volcanoes, the trees decomposing due to the mushrooms and the chemistry that's going on right there. There's so many things outside that are happening naturally, and it's just a wonderful, wonderful thing. I love to go explore. So we're going to go do that, but really quickly, I would like you to get a piece of paper and a pencil, because we have 3 activities that we're going to go outside and do. And so before we do that, I'm going to explain each one, and we're going to make some predictions or hypotheses, which are educated guesses, because we are educated people. We know how to think things through, we know how to think logically, and we know how to do step by step. I like it. So that's what we're going to do right now, okay? So let me explain my little experiment number 1, okay? We're just going to measure volume. I'm curious, so write down volume. Okay, V-O-L-U-M-E. Okay, what we're going to do, we're going to see if my liquid water will measure the same as solid ice or snow. I went outside a while ago, and look here. I've measured my cups, and I've measured my ice, and I've already measured my snow. We're just, whoops. Might do this over here. I've already measured everything out to the way it's supposed to be. There we go. Okay. We gotta get it down there, get it down there. There we go. There's my mark. Okay. So, cup number 1. Please write down cup number 1 and write liquid water. Cup number 2, ice cubes, big. Cup number 3, snow, small. Because we know that our particle here is this big solid, and these are little solid pieces, okay? So, my question to you is, when everything melts, will it hold the same amount of liquid as does the water, okay? Water is our control. This is not going to change in any way. So we have 2 variables here. We have ice cubes and we have snow, and we want to see if they will all measure the same amount. Will the volume of the liquid be the same once everything melts? So write down those 3 things. Cup 1, water, liquid. Cup 2, ice cubes. Cup 3, snow. And then tell me what you think is going to happen. Will the ice cubes have the same amount of water in it as the control as the water? Will the snow have the same amount? Will the snow have more than the ice cubes? Will the ice cubes have more? So just give me your thoughts, jot them down real quick, and we'll see all of this at the end. We'll set this aside, and as we do everything else, we'll let this melt. We'll come back and we'll see exactly what goes on, okay? I want to talk to you, because you hear me saying liquid and solid, right? So you know that water droplets, you will see them in 3 different stages, right? You will see them as a liquid, and I made a little chart here. So you see them as a liquid or solid or a gas and vapor. When you see them with a solid, okay, the little water molecules, they are all close together, okay? They get really close together and they don't move very much. They are very content to just snuggle together and just stay there, just like that. And they don't move a lot. They're stuck together, they're very close with no movement. If you see liquid like this, now think of water, okay? Think of that flowy, think of the waves. When you have a liquid, your water molecules are close together, but they're not stuck together. They're close together, and they have a flowy movement to them, okay? Nice and easy and flowy, okay? These guys will conform to whatever container that they're in. So you see how my water looks just like the cup. But does the ice cube? It doesn't. It does not conform to the cup that it's in, neither does the snow. They're solid. So they are what they are as they go in. And vapor, as I was just saying, they are very, very far apart. They're not close together, and they're always bouncing around. Bouncing around, bouncing around. Here, 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 here. I like to go here, I like to go there. Think of a bouncy house. When you get in a bouncy house, 2 or 3 people are in one of those inflatable bouncy houses. And you're here, and you're here, and you're here, and here, and you're bouncing off the sides and things like that. That's what our vapor does, okay? So that is how we can tell the difference in our states of matter. The water molecules will be situated in different ways, and that is how it forms, okay? So we're going to set this one aside, and we will wait until the end to see these results. You got everything written down for that? Beautiful. The next one over here, this is called bottle crush. And this is simply heat transfer. So when there is something warm and it touches something colder than it, what do you think happens? Good. The heat transfers from what's warm to what's cold. So think if you go outside today, we're going to go outside, we're going to pack a snowball. But my hands are warm, and we're going to wrap around that snowball. What do you think is going to happen to that snowball? Well, good. You guys are so smart. What's going to happen is your heat of your hands is going to transfer to that snowball, and that snowball is going to start to melt because of the heat transfer. So what we're going to do in a minute, we're going to take these 2 bottles, and I have some hot water. And all of these things that you I'm going to talk about today, you guys can do at home. You can even do them inside, okay? And I'll tell you how to do that in just a minute. But what we're going to do is we're going to take 2 different bottles, a big 2-liter bottle and just a regular 1-liter bottle for the smaller bottle. We're going to pour half a cup of hot water in each. Now, when you do this at home, friends, I would like you to use gloves and have an adult and be very, very careful when you do this because it gets hot. But let me give you a tip. We're going to pour hot water in both of these. We're going to put the lids on. We're going to take them outside, sit them in the snow, and we're going to see what happens to the bottle. So my question to you for experiment number 2, bottle crush. Don't know if that'll give you a hint. What do you think is going to happen to the bottle when we sit it down in the snow with hot water inside and then that cold snow surrounding it? What do you think is going to happen to the bottle? Okay, write that down. And when we carry them out, so if you do this at home, okay, you can either do it with the snow outside. If there is no snow, then we can simply use the sink. You'll take the sink, put a stopper in it, fill it up with cold water, and then put ice cubes in it. So you have ice cold water, which will simulate the snow. Then you can take your bottles just like this, pour hot as you can get it. You can try a couple of different ways and experiment with the temperatures as well. So you can try it as hot as you can out of the tap, just run it out the water. You can microwave water for 3 minutes, or you can boil water on the stove. Now, just be careful with everything that you're doing. Always have an older sibling or an adult with you, my friends, if you're younger than about 10, okay? So make sure you're doing everything safe, and let's have a good time with it. But what we're going to do, we're going to take it outside here in a minute. I'm going to talk about the last one, and then we'll go outside and see what's going on. This last one is pretty cool. I call these the crystal balls, because you're simply going to take a balloon, and you're going to take some food colors. So I've got 3 different colors. And I'm just going to show you how to do one, and you do this the same way with all of them, but just for time. So I'm going to take my food color, my balloon. I'm going to add 1, 2, 3, 4, 5, 6 for good luck. We're going to put 6 drops inside there. I'm going to take it to the water faucet, and you can put it over the sink just like that. Turn it on. Make sure it gets on here, or else it'll shoot off and you'll get really wet all over. But as you can see, it's going to be pretty green. You want it to get it pretty good size, but make sure you still have enough that you will be able to pull that off. I set it in the sink. Helps me balance it. Then I tie it. Again, if you can't get those around your little fingers, there's always somebody that's helped. So look at this. This is beautiful. Now, here's my question to you guys for experiment number 3. We're going to take our balloon outside, and we're simply going to set it in the snow, and we're going to let it sit there for 24 hours. Now, I've already done some, so we can see the effects of it, okay? But you would take these, and you will do as many colors as you want. I just did a green one to show you, but red, yellow, purple, whatever, however many you want. Then we're going to take them outside. What's really cool about these is when they're done, we can use them as decorations for as long as it's cold. So this is really cool. So what we're going to do now is we're going to get our coats on, and then we're going to pour our hot water and take it straight outside, set it in the snow, and start watching what happens. And again, make your observations. What do you think is going to happen, and how long do you think it's going to take it to happen? Okay, so let me get my coat and then we'll be right back. Hey friends, has everybody got your coats on and your gloves? Because you're going to want your gloves on when we do this experiment, okay? So you guys have your hypothesis written down for experiment number 2. We have 2 bottles. We're going to put hot water, a half a cup in each one, put the lids on, take them right outside, put them in the snow, and we're going to see what happens. What do you think is going to happen to the heat of the water inside? What do you think is going to happen to the water or the pop bottles themselves? Okay, I just microwaved my water for 3 minutes, so I'm going to grab it. And this is where it's really, really hot. So make sure you have help doing this so you guys don't hurt yourselves at all. And I'm going to pour in a half a cup. And very gently and carefully pour it in here. That's why I have my pan, just in case. Now you're going to feel heat. I want you to put that lid on really quickly, and look, my vapor is already starting to rise. If you look in your bottle, you're going to see that vapor or gas forming in there. Now I'm going to do the same on this side. We're going to put it in here. Oops, over there. And we're going to go right outside very quickly, and we're going to see what happens. Join me outside. All right, friends, ready? Here we go. Now start watching. Look at this bottle already. What's happening right here? Can you close in on it? Get a close-up? What's happening to my bottles already? Oh my gosh, look at that. Look at that, my friends. What is happening to the bottles? Look how they are crushing in. Now, why is that happening? How cool. And how long did it take? It was just about instantaneous, wasn't it? When that warm water touched that cold water, and like we said, when I make this snowball and my warm hands start touching that snowball, it's already starting to melt. But it has got it's light fluffy, but when I press it together like this and it starts melting, then some of that water refreezes and freezes it into a solid piece. How cool is that? So that is what's going on. We are having heat transfer. So the hot water transferred the heat out here to the snow, and that caused our bottles to cave in just like that very quickly. Now, I didn't really get to see. Did you see which one was able to do it quicker? I'm thinking it was the smaller one. And why would that be? That would simply be because we have a smaller volume. So we have a smaller area for that to work on. So that's what happened right there. So, nicely done. I really appreciate that so much. While we're out here, I also brought our water balloon. And what we're going to do with this, once you get your water balloons, however many that you want, we're going to take them outside. I have a couple right there that I've done already, and we're going to see those in a minute. You're just simply going to drop them in the snow just like that. You're going to let them last and sit there overnight if possible, or for as long as the weather will allow you to do. Now again, this is another thing that you can do inside, my friends, because if we don't have the snow like this, we can just fill up our water balloons with the colors just like that, and then we can stick them in the freezer for 24 hours, and then hopefully we'll get the same results. Now, when it's down here like this, we're going to hope that it's going to come out to be a really, really cool design and effect here after a while. Okay guys, welcome back inside. I got my coat off, I warmed up a little bit, and I cleared off our space a little bit so we can see what results that we have from what we've done today. I'm going to slow down a little bit because I feel like that I went through the directions of all this stuff really fast earlier just so we could get outside and play. So let me slow down a bit. Let me explain things a little bit more. And let's see what we got, okay? So when I said that this was an experiment just looking at volume. Volume, simply put, is the amount of space that an object takes up. For instance, my liquid water, or our control on this experiment, it takes up this amount of space in the cup. So this has the volume of this much in this cup. What I did was put 1 cup of water in this glass, 1 cup of ice cubes in this glass, if you remember, and 1 cup of snow in this glass. What I wanted to see is these, in these 3 glasses, will there be the same volume of liquid once the ice cubes and the snow melted? So, what do you think our results were? And here's what I'm going to do. I don't know how well you can see that. So I'm going to put a couple of drops of green color into our water just so you guys can really get a good look. Okay. What do you see, my friends? Is the volume of the liquid snow the same as the volume of the liquid ice cubes? Is that the same as the liquid water? Well, it's not, is it? Look at the difference that we have here. So our snow came right to here. Our ice cubes. And then, of course, our water. Now, our water stayed the same the entire time, right? It didn't change. That's why that was our control. And our 2 variables, or the 2 things that were changing and we wanted to look at, was in this cup and this cup. Now, my question to you is, was your hypothesis the same as what we're seeing, or was it different? How many people thought it's going to be the same across the board? Because we started with the same amount, right? Who thought maybe that this would be the same, or this would be the same? Did your results come out like what the results showed here? Okay, I like it. So my next question is, why do you think it happened just like this? Why was the snow volume less than the ice cube volumes, which was less than the water? Look down here at my chart and you might remember. So remember how things work. So we had 2 solids right here, right? So how did those 2 solids look when we poured them in? These were big ice cubes, and these was snow. So they're little bitty ice particles, a whole bunch packed together, okay? So we see what we see because the ice cubes were bigger. I have a couple of fake ice cubes. The ice cubes were bigger, right? And they were stacked on top of each other, and they had some holes, so they had some empty space in that cup. My snow are tiny little ice pellets, and there's a whole bunch of them stacked together. So there was a whole lot of little holes in there. So there's a whole lot of empty space in this glass, actually, because all the holes that were intermingled with those particles, where my big solid pieces only had a few empty spaces. So, what did you think? Awesome? I like that. Okay, let's move on to this one really quick. And I don't think that I have to explain a whole lot about this one because I think I explained this one really well earlier. But look how that heat exchange crushed those bottles. How cool is that? Take this outside and check it out if you have snow. Again, you can do this in the sink. Fill your sink up with water and ice. Put your hot water inside your bottles and very carefully stick it inside the sink and check out what happens. That's really cool. You can do this one as well at home. You use water, big ice cubes, and then you can just crush some ice up and use crushed ice for snow. Same effect. Okay, let's move on to this one really quickly because I don't know what's going on. I want to check this out. These are the snow, the crystal balls that I took outside earlier. The one that we took outside a while ago is still out there. It's going to take about 24 hours to really get nice and frozen so we can do this. Now again, this is one that you can do inside. You can take your balloon, fill it up with the water and the food coloring, and then stick it in your freezer for 24 hours and you're going to get the same effect. So what we're going to do really quickly, and this is cold too, so you might want to put gloves on to do this part, and always have your adults help you with this. I'm going to move. It's starting to warm up and my snow's starting to pop. So I'm going to move this over to the side so we can see this one. Now I have a piece of foil under here just so we don't get anything wet. And remember, this is food color, so it will stay in your fingers and stuff. We don't want it to stay in the counter or anything, so we're going to put it in the container and some foil underneath it. And I'm simply going to pull this part up where you tied it. So I'm going to cut it off right here. And I'm going to get my glasses on, friends, because I need to see what I'm doing. Then I'm going to pull it up and I'm just going to cut. There we go. And tear. We're going to see. Look at that. Now I'm going to come a little closer because I really want you to try to see. And I'm hoping that it's right here. Good. Look at that inside. Now this kind of simulates what's happening up in the air when that warm air and everything, the cold air hits each other and the snow particles start coming together. You have that crystallized, I don't know if you can see those crystals running through there. But that is just absolutely beautiful, and that's what's going on up in the clouds when everything forms, right? How cool is that? That is just so beautiful. Just so beautiful. I want to look at the green, so let's do the green one real quick. These are just too awesome. And when we get done with these, friends, please make sure you dispose of all of the balloons in the proper trash receptacle. We never want any of our wildlife to get a hold of anything like that because that could be really dangerous for them. So always make sure that we put everything in its proper place when we're done. I love it. I said green, but I went ahead and grabbed the red one to check this one out. These are fans. Ooh, okay. You can even see this one. I hope that I'm getting in the right spot. Look at how that just shoots out of there. Oh my goodness, that is just beautiful. Look at all the spikes on there, all of the icicles that's formed in there. That kind of looks like a porcupine in there. Ah, these are fabulous, my friends. Fabulous. Fabulous. Let's do the green one really quick. One last time. Or not. My scissors don't want to work anymore. They're getting cold. There we go. Just because I'm too curious. Beautiful. And each one came out differently, just like snowflakes do. They are all different. How beautiful is that? I'm going to sit this one over here because I have one last question for you before I go today, friends. When it snows out there and the roads are all snowy and slick and stuff like that, you will see the road crews putting salt on the roads. Now, why are they putting salt on the roads, do you think? You're absolutely right, is to melt the snow. Now, how does that happen? Oh, you guys, you're great. It's a chemical reaction, right? Salt, okay, is made up of sodium and chlorine. And so when those chemicals hits the ice, it starts breaking apart the water molecules, okay? Think of a solid, right? Everything is all close together and nice and snuggled right up against you. We're not going anywhere, are we, friend? I like it. We're a solid. But when I have ice, we're just going to put some on this white. See what happens? When I put it on here, it's going to actually start melting the ice. What happens is the chlorine and the sodium, gets in here, and it's a chemical reaction, and it starts breaking the water molecules apart, and that will start causing holes or air pockets, and if you can hear it, it will actually start crackling. Then it will start melting that ice, and that is how and why we use salt on the snows. And I'm just going to add a couple of drops, but it will follow the direction of that melted snow. And now look at what an awesome, and I can't move anymore because we're starting to melt pretty good, because that is what the salt is doing. But look at that beautiful crystal ball we have made today. Isn't that awesome? All right, my friends. Woo! That's cold. Little green hands, too. It washes out with soap and water with no problem. All right, my friends. I hope you enjoyed today's session with me. I love snow. I hope you go out and enjoy some. But if you're somewhere where it did not happen for you, all of these things we can do inside in our own kitchen and have a good time. So, my scientist friends, find something, go out and enjoy it. But definitely grab your adult and go enjoy your naturehood today. And I will see you later. Bye.